finally time to do redox, one of my favorite categories. So redox is shorthand for oxidation and reduction reactions. So in a redox reaction, you have oxidation and reduction going on at the same time. So what is oxidation and what is reduction? Oxidation is any reaction where there are electrons that have been lost. So a way to remember that is Leo the lion. Leo stands for lose electrons is oxidized. Leo, Leo. Reduction is when something gains electrons. And the way to remember reduction is GER, G-E-R. Gain electrons is reduced. So the way to remember that is Leo the lion goes GER. So let's give an example. In an oxidation reaction, one thing loses electrons and something else gains electrons. So together, what really happens is electrons are transferred. So one example of a redox reaction would be a synthesis reaction. We'll go with copper plus oxygen. So we'll use copper plus oxygen makes copper 2 oxide. So what really happens in this reaction? Well, in order to figure it out, we need to see what the charges are on everything. So one simple rule is if it is an element, the charge is always equal to 0. The other thing is that in a compound, the charges altogether equal 0. The individual parts of a compound have what we call oxidation states. Oxidation states, you might remember from earlier in the year, are just the charge that each ion acts like it has. So in this example, we start with copper, which is an element. So its charge is 0. Oxygen, which is diatomic, so actually gets a little 2, also has a charge of 0. Okay. Now in order to make this reaction work, of course, we would need to balance it, 2 coppers and 2 copper oxides. But that isn't really that important for this part of knowing what's going on. So the next thing we have to do is find the charges for the copper and the oxygen in the compound copper 2 oxide. So we know that oxygen always has a -2 charge. So that's the good news. We can start with that. Oxygen is -2. So then we just have to figure out if we add together copper's charge plus oxygen's charge, we have to get 0. Oxygen is -2. So when we add 2 to both sides, we find out that copper has a charge of +2. This is something we could have already done because we do this when we name compounds all the time. That's how we know it was copper 2 oxide. It has a +2 charge. But what you're going to be asked to do with redox reactions is find out what got oxidized and what got reduced. Okay, oxidized is the Leo part, whatever loses electrons. So if we look at our reaction, copper went from a charge of 0 to a charge of +2. And oxygen went from a charge of 0 to a charge of -2. So in order to become positive, did we gain or lose electrons? The answer, of course, is that we lost electrons. That means that copper is the thing that got oxidized. Oxygen gained electrons. That means copper got reduced. Once we've found out what's been oxidized and what's been reduced, we sometimes want to know about the oxidizing agent and the reducing agent. So an oxidizing agent is something that makes another element get oxidized. And so one way to tell that you have an oxidizing agent is that it is the thing that got reduced. So that means that the reducing agent is the thing that got oxidized. And the reducing agent is something that makes another element undergo reduction. So they always occur in pairs. When you find out what got oxidized, that is your reducing agent. Whatever got reduced is your oxidizing agent. One of the cool things about redox reactions is that they're actually really practical. There are some real life examples where this is going on. Probably the thing you're most familiar with is batteries. Most of the batteries that you put into your electronic devices are actually little chambers where there's a redox reaction going on. And that redox reaction makes the electrons move. Another application that some of you might be familiar with is called electroplating. So anybody who has something that's made out of a metal and it's just coated in gold, or your silverware is usually made out of something inexpensive like aluminum and then coated in silver, the way they do that is through a process called electroplating. And that is actually a redox reaction. also used in boats. They put a piece of metal, it's actually two different metals touching each other, on the bottom of the boat. And the purpose of that is for the salt that's in the ocean water to make those metals rust before the metal on the boat. So you can actually prevent rusting on the metal parts of things that are in water by putting an anode on them, which is kind of cool. What I'm going to show you here is a picture of a voltaic cell. Okay? A voltaic cell is basically a battery. Okay? So in this voltaic cell, what is going on is that we have copper, just a piece of metal copper, and it's sitting in a solution, in this case of probably copper sulfate. But it doesn't really matter what it is, any copper salt that dissolves. And on this side, we have zinc. And this zinc electrode is sitting in zinc sulfate. How do I know it's zinc sulfate? Because we have the sulfate ions listed right here. Okay? And there's a wire that attaches the zinc and the copper to each other. And that lets the electrons go from one place to the other. Because it's a battery, we need an electrical circuit. So what we have here is called a salt bridge. The salt bridge is a piece of glass tubing with some sort of salt water. In this case, the salt is sodium sulfate. And the point is that the sodium and the sulfate don't actually react at all. They're neutral. They're not going to create precipitates with anything that we have in our two solutions. And what's really moving are the electrons. That's why we call it electricity, because the electrons are what's moving in there. So in this case, we have an anode with zinc. And at an anode, we have oxidation reactions occurring. Okay, the anode is where oxidation happens. That's where we're losing electrons. Okay. The anode in these cells is what's going to get dissolved. So in our example here, zinc is the anode. And what happens is that the electrons are leaving the zinc. And they're going to travel up the wire. When the electrons leave, the zinc metal becomes zinc ions. They dissolve into the solution. So we have our negative charges going up the wire. Okay? Now, those negative charges have to be replaced somewhere. So sulfate from the salt bridge goes in and fills in. So we start getting sort of a very negative solution in here, which allows electrons to continue going up our zinc electrode. The electrons go through the wire, and they go down to the copper, the cathode. Okay, remember anode, anion, negative, cathode, cation, positive. Okay, the electrons go into the cathode, right? Negatives move towards a positive charge. And what's happening on this side is that copper ions from the solution are seeing this negative charge from the electrons. And so the copper ions are jumping on top of this. And so this is actually getting thicker, or sometimes longer, depending on how you look at it. But the copper is getting coated onto this plate right here. So on the cathode, we're gaining electrons. We have a reduction reaction going on. So the cathode is always the reduction. It's gaining electrons. And this is getting thicker. So if we're trying to put silver plating on silverware, we might have the fork sitting at the cathode. Okay, the fork would be sitting right here. And instead of having copper in the solution, you would have silver chloride in here. And when the electrons come down here, the silver ions take in those electrons and form a thin coating along this plate. Okay, and then of course, since the electrons are coming here, we have our sulfate ions going up through the salt bridge, and we have sodium ions coming back down in here to sort of replace that charge, because the point of the salt bridge, again, it lets the electrons move, and it helps keep our solutions neutral so that the reaction can continue. So how is it that we remember that oxidation is always occurring at the anode, which is the negative side of the battery, or the voltaic cell, or even an electrolytic cell? Cathode is positive side. So how do we remember that reduction is going to occur at the cathode and oxidation is going to occur at the anode? The phrase is anox, red cat. Anode is oxidation. Okay. You would never say aox, and you would never say an cat, but you do say anox, so that's really easy to remember. Anox, anode is oxidation. And then red cat, reduction occurs at the cathode. So the two phrases that will help you most when you are doing electrochemistry or redox reactions is Leo the lion goes grr, lose electrons oxidation, gain electrons reduction, and anox, red cat. Oxidation at the anode, reduction at the cathode, and you need to be able to make sure that you can always put the charges on every element in a compound. And so I do want to do one practice with you on putting the charges, what we call formal charges, into a compound. So I am going to use sodium sulfate as my example. So sodium sulfate overall has a charge of 0. And that's equal to 2 times the sodium charge, why 2? Because there are 2 sodiums, plus the sulfur charge, plus 4 times the oxygen charge. There's only 1 sulfur, there are 4 oxygens. That's where those numbers come from. I know the charge of sodium. I know the charge of oxygen. Okay. Oxygen is always a -2. Our metals, we know what their charge is from the periodic table. Where we run into trouble is if we have a transition metal and in the nonmetals, because most nonmetals actually can have more than one possible charge. So what we're going to do right now is figure out what the charge of sulfur is, because I already know sodium is a +1, and I already know that each of the oxygens has a +2 charge. So I have 0 equal to 2 times the +1 charge, plus X sulfur, plus 4 times the -2 charge. So 0 equals +2 plus X minus 8. 0 equals X minus 6. So X is equal to a +6 charge. That +6 charge is spread out over every sulfur atom I have. In this particular case, I only have 1 sulfur. So the charge on my sulfur is a +6. Okay, that might not be what you expect. Looking at the periodic table, you think it's going to be a -2. But in this case, sulfur has a +6 charge. So please, if you're asked to find the charge of an element in a compound, please make sure that you go about assigning charges in a way that makes sense. Oxygen will always be -2. Hydrogen is often a -1 when it's in a covalent compound. It's +1 when it's part of an acid. Most of your other elements, if it is just the element by itself, its charge is 0. If it's a metal, you can find it by using the periodic table. Column 1 has a +1, column 2 has a +2. For your transition elements and for your non-metals, you have to be careful and actually figure it out the long way.